My name is Mike Hawes and I'm an application engineer with Agilent Technologies. Today I'm going to show you a new solution that Agilent has for medical device designers, in particular wireless or mobile medical devices. This new solution gives them the ability to look at transient activity from their medical device, which will give them additional insight into characterizing and predicting their battery life. So let me show you the solution that we have. This is a DC power analyzer. It's a general purpose R&D tool for an R&D bench. Has 4 modular supplies. We're only using one of those. And we have it connected to a wireless blood pressure monitor. This is actually the world's first Wi-Fi wireless blood pressure monitor. We'll be using this as our medical device for our experiment today. Channel 1 is connected to an SMU, or a Source Measurement Unit. The unique thing about this Source Measurement Unit is that it has 4 current ranges. 3 of those you can actually switch between seamlessly. And this is a patented technique that we have that gives you 28 bits of dynamic range. This enables you to measure the sleep currents at 10 microamps and the execution or operating currents, for example, when you're transmitting RF at, say, hundreds of milliamps. And then finally, we have our software that's controlling the system and going to be presenting the information that will give you that additional insight. So let me go ahead and turn around and get started. As you look at the SMU, it's at 6 volts, so we're simulating the battery in our medical device. I'm going to go ahead and start the data logger, and we're going to log for 5 minutes. So here you can see the basic data logging has started. I'll go ahead and put on the blood pressure cuff. And I'll take my blood pressure. You can see from the device here that its pump is going. You can probably hear the pump starting. This process takes probably about 5 minutes. So now that we have the data log, let's take a look at the current trace. You'll notice that I have a couple of markers that I can set up. And so I'm going to go ahead and move those markers. And the first thing I'm going to look at is this peak. This was a peak when it turned on the pump and the blood pressure cuff was squeezing my arm. And you can see that the peak for this is about 570 milliamps. We can also use these markers, and I'm going to move to the sleep mode when the device was sleeping. And here we can see that the average is 53 microamps, but the minimum and the maximum are only 5.8 microamps peak to peak. So we've got considerably less sleep current. This level of accurate measurement is not available with a standard technique. It's the seamless ranging that allows you to both measure that peak at 570 milliamps and this sleep current down at 5 microamps, or excuse me, 53 microamps. We also have something else that's interesting, and this is where you get a lot of insight, and it's the charge per energy. What we end up doing here is understanding how we're depleting the capacity of the battery. So I can go ahead and move these markers throughout the whole cycle of taking my blood pressure and see for every time you take a blood pressure measurement, you're going to be depleting the battery by about 2.1 milliamp hours. So this is a software gives you very good insight into being able to determine and predict the battery life for your medical device. So that's pretty much it in summary. We've used the wireless blood pressure monitor, blip, And we've shown how our solution provides you good insight as a designer to predict and maximize battery life for your medical device. Thanks for watching.